Hey folks, I wanted to give you a couple pointers on today's homework. I know some of you remember a lot of this stuff and you're like, come on Nelson, let's move a little faster. But we want to be experts at polynomials, right? So here's a polynomial. You can see the zeros are at -2 and over here at 3, right? So how do I see that? Well, they're the zeros of the polynomial. If I stuck -2 in here, or if I stuck 3 over here into this factor, you get 0 for the y value, right? Now, we talked about behavior near those zeros. If you're really close to 3, this guy comes down and touches or is tangent to the x-axis and then goes back up because of that squared. It's behaving just like a parabola right in here. And then because the power here is a 1, it's just crossing through at -2, right? So this is all section 1 information, okay? If I go to this other polynomial here, you can see this one has a couple turning points. If I can zoom out enough, here's a turning point, here's a turning point down here. The degree of the polynomial would be 3, right? If we multiplied all this out, we'd have an x cubed somewhere. And the number of turning points, or at least the max number of turning points, is 1 less than the degree. So if we had a degree of 3, at most we could have 2 turning points. We might have no turning point at all. We might have 1 turning point. Yeah, so I know for me that information isn't all that helpful. Like, what's the maximum number of turning points? But they're going to ask about that again just in today's final assignment on section 1. Now, why in the heck are we doing another assignment on section 1? Well, rational functions are just 2 polynomials that are divided, one in the numerator, one in the denominator, right? So, but you can see, man alive, rational functions are way more complicated. What makes them more complicated? Well, we've got places where the function's not even defined, right? Like here, it's not even defined, right, at x equals, let's see, what is that number right there? Well, g of x is in the denominator, right? So if I plug a 6 in here, I'm going to get a 0 in the denominator, which is not allowed. That's what generates the vertical asymptote at x equals 6, right? So, we often draw these things with dashed lines, the asymptotes that is. Woo! It's early in the morning. So yeah, the asymptotes are usually drawn as dashed lines, right? Because they're not really a part of the function. They're just showing people where the function is undefined. Okay? Well, man, that's a lot of information, right? So I asked you guys to, organize your notes. We have something like this on the whiteboard. As I look up there, we have p of x in the numerator, q of x in the denominator, right? And then if they're in factored form, it's real easy to find where the zeros are. We cannot have zeros in the denominator. That's what we want to restrict for our domain, right? So we don't want to let x equal, like in our problem over here, we don't want it to be a 6, we don't want it to be a -5, we don't want it to be a 0. That's why there's a vertical asymptote at 0 and over here at -5, because the g of x polynomial is in the denominator, right? So being able to see where the g of x function goes to 0, right, is going to tell you where the vertical asymptotes are. I think that's pretty easy, right, to determine the vertical asymptotes. The horizontal asymptotes are kind of like a whole nother ball of wax. And what we're doing for horizontal asymptotes is we're looking out here. We're looking at the end behavior. What does this guy approach as we get closer and closer, or x gets larger, if you will, if it gets closer to -infinity? You can see that it looks like it's going toward 1. Why is that? Well, we said that to determine the horizontal asymptotes, you really need to look at the degree of the numerator and the degree of the denominator. So let me put that down here. So we're looking at the degree up here and the degree down here, and we're making some conclusions about that information. Now today we don't have to worry about that in our homework. We're not doing a whole bunch of of rational function problems today. So let me jump over to the homework, and I want to show you what we are doing. We're gonna do a little review of zeros and how does it behave near that. So if you notice here, it's talking about end behavior though, right? And as x gets really large, this polynomial right here, the most important part would be the x cubed part. So it's going to behave just like an x cubed function at the ends. I hope you remember that. And let's see here. Let me go through a couple more here. Find the x and y intercepts of the graph. Well, the x-intercepts would be when the y value is equal to 0. So what's going to make all this 0 over here? Well, if I stick a 0 in right there, I would be at 0, 0. If I stick a -2 in there, I would be at -2, 0. So I remember this, that 0, 0 tells us the y-intercept, right? So when I stick 0 in here, I get a y value of 0 as well. And then it says determine the zeros of the function and their multiplicity. So we've kind of already done that. I mean, you might be thinking, well, why are they making us do that again? I'm not sure. I think they're just trying to emphasize that the vocabulary, the zeros, mean the same thing as x-intercepts for our polynomial. And then this is a little confusing. The lesser 0 is the -2, right? So the -2 is my lesser 0. And if I scroll back, well, I don't need to scroll, but the power is 1, right? So my multiplicity is 1, which means that it crosses at, oh, wait, I need to put this as 1. I don't want to list my multiplicity. I want to say what it is. And then over here I list it. That's -2, right? And the greater one at 0 has a multiplicity of 2, right? And that means that it touches, right, at the x-axis, okay? So that's a little confusing, that last problem right there. Determine the maximum number of turning points. That's super easy. The degree of the polynomial is 3, so it's going to be 1 less than that, all right? Hey, I hope this video helps you get through some of the homework as you're, trying to figure out what the polynomial looks like. These all look alike until you kind of zoom in on them. And then you can see that it's crossing and it comes up and touches. So go back and study which one do you want there. I think we said it was an x cubed, right? So it should be down on the left and up on the right. So these two are sucker answers over there. And then we said that it crosses at -2 and it touches at 0. So let's see what this one looks like right here. If I zoom in, it crosses at -2 and touches at 0. What's the difference between this one over here, though? Oh, see, it's touching at 0 and then it's crossing at +2. Oh, they're trying to mess with us there. It's supposed to be this one right here, right? It's gotta be at -2. Man, I hope I'm making this clear. Okay, so hit that little zoom in button down there. Thanks for watching my video. Take care.